Hello everybody, Jesse here from Jess-Inspired. How you guys all doing? Anyways, today we're going to be discussing about the Strtok function. And someone probably is thinking right now, like, Jesse, you did not mention this in the first video where you talked about the 7 concepts to build our own shell. Well, I've come to see that you also need this. Alright, so if this wasn't necessary, I wouldn't be bringing it up right now. Anyway, so today we're just going to be discussing the concepts of the Strtok function and why we need it. And then in the subsequent videos, we're going to use it in building our own shell program. Alright guys, so without further ado, let's just get started. So guys, let's now discuss why we need the Strtok function in the first place. And as usual, I'm going to give a very minimal explanation so it's beginner friendly, okay, and it doesn't spook you guys. So first things first, usually when you read lines using get line, so if I have something like ls-la, right now, if I read this using get line from my standard input, which I'm doing right now, what get line will do is that get line will read this entire line, isn't it? So get line is not going to break this into any segments. It's just going to read this entire line. So I'm going to have ls space hyphen la. And that can be good if you just want to print out stuff to your terminal, but if you actually want to execute this as a command using execv, you need a way to be able to tell which of these strings is actually, or which part of this string is actually a command and which of them is arguments. So what Strtok does is that it's going to break down this string into different segments called tokens. That way execv is able to tell that, oh, okay, this is actually the command, and this right here is an argument to this command. So I hope that made sense. So let me just show you something right here in our man pages to elaborate what I just said. So right here, guys, as you can see, there are two functions that are specified, Strtok and a sister function, Strtok underscore r, which is beyond the scope of this tutorial. But basically what they do is that they extract tokens from strings, just as we talked about. Right here, you can also see the syntax of the Strtok function. And as you can see right here, it returns a pointer to a char, as you can see right here. And it accepts two parameters. The first of them is the string that you want to tokenize. So the process of extracting tokens from strings is actually what is referred to as tokenization. So you can add that to your vocabulary. And then just in case that's a new word. And speaking of new words, we have the second parameter, delim. Delim actually stands for delimiter, and if that's a new word for you, delimiter is simply one or more characters that separates text strings, and I'm going to show you how these work together right now in code. So right now, let me open up this file, strtok.c. So for starters, you want to make sure you include the right header file, which happens to be string.h. So I have mine in my source file. So if you have yours included, let's go ahead and explore what I have right here. So first things first, I have a character array that says Jesus loves you, just like that. And right here, this happens to be the string we want to tokenize. So I want to break it down into 3 different strings. Jesus loves you as 3 different strings. To do that, you realize that what separates each word in this string or each segment in this string is a white space. So I have my delimiter specified to be a white space. And then the third variable right here is the pointer that would hold the tokens that will be returned by Strtok. So everything looks good for now. Let's go ahead and call Strtok. Okay, so Strtok. And I'm going to pass in the string str, and I'm going to pass in the delimiter, just like that, delim. Next, I'm going to do a printf %s, and let me pass in token, just like that. So I should expect to see that this will be broken down to Jesus. Okay, so just Jesus will be returned right now once I call this printf function to print out what's stored inside token. So let's go ahead and do this right now. So gcc. So everything seems to be working well. That's good. Let's go ahead and play with this some more. Right now we've been able to extract the first token, but what if I want to extract the second token? So to do that, as usual, I'm going to call Strtok one more time. I'm going to do token equals to Strtok. But this time around, I'm not going to pass in this string str. So check this out right here in my man pages. It says on the first call to Strtok, the string to be parsed or tokenized should be specified in str. So that's what we did right here. This string was actually specified right here. But it says in each subsequent call that should pass the same string. So this is the emphasis, the same string. So right now, if you've actually called string token on a string and you've extracted the first token, just in case you want to extract the next token from the same string, the first parameter str must be null. So I hope that made sense. So to show you what I mean in code, I'm just going to pass in null right now. And I'm still going to use the same delimiter because it's still a space I'm using as the delimiter. And this looks good. Let me do a %s space token, just like that. And then let me save this and run this. So everything is working according to plan. Let's take this a little bit further, shall we? So right now, if you realize with this pattern I'm working with, I would need to be calling string token for as many times as I want to tokenize a string. So just in case I have 10 words or 10 tokens in a string, I'll need to call string token 10 times, which is not a good way to code. So it's not good practice to do that. So I could actually achieve the same results using a loop. So in my case, I'm going to use a while loop to do it. So to do that, let me just wipe this off right here. So first things first, you want to make sure that you call string token the first time, passing in the string that you want to tokenize, which I've done right here. Next, I'm going to write my while loop just like that. And to use the while loop, I will need to take advantage of the return value of string token. So if you check right here, it tells us that the string token and the string token underscore r functions return a pointer to the next token. So just in case there are more tokens, it's going to return a pointer to the next token. Or null, so this is the information I want you guys to take note of, or null if there are no more tokens. So this while loop will run as long as token is not equals to null. So I'm going to write that just like that. So while token is not equals to null, or you could make this even much more syntactically better by just writing while token. So this is the same thing as on what I wrote previously, while token is not equals to null. So first things first, I'm going to do a printf to print out my token. Okay, so currently I have Jesus inside here right now. So this will print it out. Okay, just like that. Next, I'm going to call string token again and assign the value to token just like that. So I'm going to do string token. Since it's a subsequent call, I'm going to call passing null and the same delimiter is expected. So right now, let's just go through what would happen. So string token will be called the first time. Jesus will be stored right here in token. So for the first time, the while loop is actually executed. Jesus will be printed out with a new line, and then string token will be called again on the same string because I have null right here, and loves will be stored right here in token. So it's going to do a check to find out if loves is null. Since loves is not null, it's going to print it out and call string token again for you, do the same thing and call string token again. But right now, since there are no more tokens, what will happen is that this token will be null. And then when it comes right here to check in the while loop if token is not equals to null, since token right now is null, it's going to exit the while loop and return from our main function just like that. So let me go ahead and save this and run it. Let's go ahead and compile this. Bullseye, check this out, guys. I have everything all working as expected. So let me just show you guys one more characteristic of string token and we'll be done. So I'm going to change this from a character array to a string literal by simply making it a pointer to a char. And I'm going to run this code again right now to see if it works. So right now you realize that we're having a segmentation false with a string literal. Let's tweak this code again, and this time around let's store our string on the heap using malloc. Let's allocate memory dynamically, and to do that I'm going to include this header file stdlive.h, and to make this much more descriptive, I'm going to call this source because I'm going to be copying this string into the memory which I'm going to allocate right now. So I'm going to say malloc size of char multiply by the length of this string, just so that I have enough space in memory to hold this length of string. So this would be src. This looks good. Right now, I'm going to come right here and do a string copy. So I can copy the string from my source to my destination, which happens to be str in my case. Yes. So from source to str, this makes sense. So let me save this and run this and see what happens. So as you can see, guys, with memory allocated on the heap, you realize that our code is still working. So when we use the character array, our code worked. When we allocated memory dynamically on the heap, our code also worked. But when we use the string literal, our code didn't work. We had a segmentation fault. And then let me quickly explain to you what's happening under the hood. So if I come right here to my man pages and I check the 5th paragraph of my description section, you see something interesting that it says. It says right here that the end of each token is found by scanning forward until either the next delimiter byte is found or until the terminating null byte is encountered. So it says right here that if a delimiter byte is found, this is what I want you guys to take note of. It is overwritten with a null byte to terminate the current token, and Strtok saves a pointer to the following byte. That pointer will be used as the starting point when searching for the next token. So in essence, what happens is this. Strtok basically scans through this string until it encounters either a terminating null byte or a delimiting byte. So in our case, after S in Jesus is going to encounter a terminating null byte right here, being a white space as we specified. Then Strtok will store the address of the next non-delimiting byte, which happens to be L in this case. And when it does that, it's going to modify the original string by inserting a terminating null byte right here in place of the delimiting byte. Okay. And when next Strtok is called, it's going to also scan through this string from here, from loves, from L right here, until it encounters another delimiting byte, being a white space right here. And it's going to store the address of the next non-delimiting byte, being Y in U. Then it will modify this delimiting byte to a terminating null byte. Next, Strtok will scan through from Y in U, and it's not going to encounter any other delimiting bytes. So it's going to encounter a terminating null byte here at the end, and it's going to return null. So basically what I'm saying in essence is that Strtok modifies the original string. So this behavior of Strtok right here explains why we had the segmentation fault. We're trying to use it on a string literal. Because unlike a character array that is stored in the stack, or like the string that we actually stored on the heap using malloc, string literals are put in a read-only section of memory and therefore cannot be changed. So when Strtok actually scans through the string and encounters a delimiting byte, he actually tried to modify that delimiting byte to a terminating null byte, but because it's a string literal and it can't be modified, we actually tried to access an illegal memory address, and the implication was a segmentation fault. So I hope this made sense. So that's it for the basics of the Strtok function. So I trust you guys enjoyed this. If there's any part of this video that seems a little bit confusing, go ahead, watch it again, watch it at your pace. I've also linked a tutorial in the description below from Portfolio Courses, on Strtok, and he does a great job explaining this concept. So I learned a lot from him. So you might also want to consider checking out his channel. And if you're new here, you might also want to consider subscribing so you can be up to date with the videos which I'll be uploading. And if you like this video, go ahead and give it a like. If there's something you want to say to me or something you want to add concerning what I've said so far, you might also want to drop a comment, so your comments are very much welcome. And that's it from me for now. I'll see you in the next one.